final operation, we reach the most exciting part, finishing the presentation side, the outside of the drum. It's perfect timing too, because we just received this MCD tool from Horn, which I'm hoping will give this drum a mirror-like finish. You'll see a lot of tool paths similar to those in previous videos. We're going to come in and semi-finish the outside of the drum so we have a nice, consistent surface all the way around before moving in with our MCD tool. The tool we're using to finish this part is a specialty tool made by PH Horn. It's a monocrystalline diamond, MCD, insert brazed onto the carbide shank of the tool. The great thing about this MCD tool is that you can run it at a very high surface footage. We're going to spin it at 18,000 RPM and feed it at 100 inches per minute while still getting a great finish. Since our original part has a mirror finish on the inside, I'm going to take a 0.002 inches 2000s step over with the tool. As this starts running through here, the first thing we're going to talk about is the tool itself. As you probably already guessed, it's an MCD, a monocrystalline diamond. This particular one is a circle segment lens cutter. It's a 10mm diameter tool, or 0.394, with a 100mm radius along the bottom and side. Using this is like using a 200mm diameter ball nose cutter, even though the tool itself is only 10mm in diameter. To get the contact point closer to the edge of the tool, I'm tilting it up by 2 degrees. A diamond tool doesn't go all the way across like a standard ball nose because diamond tools are extremely expensive to make, so they've only given us about 4mm of diamond along the bottom and side. Another thing I'm doing is timing the spindle to control how the chip is formed. What I did was indicate the insert flat and then rotate it back. That keeps the chip from scratching the surface we've already cut. You'll also notice as this runs across the part that the programming starts to look a bit more efficient. That's because I hand rotate using a macro. I did that because I didn't want the spindle to lift up and come back down on every pass as it moves across the part. Every machine has a positional and repeatability accuracy limit, meaning there will always be some error or backlash, even if it's minimal. In SolidCam, I created a normal surface milling toolpath, deleted the spindle command, added the positional rotation I wanted, and used that toolpath. I actually got some of these ideas from a channel called Breaking Taps.